Then you have the increment, so it will increase the value by 1. This is the sign plus plus, so let's try A. Let's A plus plus. Okay, so let's try it. So if we put a number, it should be plus 1 since we increment it by 1. So if we put 6, it should give you A plus plus. I think it should be here. Let's try. If we put 6, it should give you 7. So that's the increment operator for your arithmetic operator. So it's plus plus and then the variable. Let's try another. Let's say 45, so it should give you 46. So that's the increment. And how about the decrement, meaning it decreases the value of a variable by 1. So let's try decrement. So this is a decrement sign, a double dash, and then the variable. So let's try it. So if we enter a number, let's say 100, it should give you 99, like this one. Let's make this font, make that 36. Okay. So that's the increment and decrement of a number under arithmetic operators. So we go to assignment operator. So assignment operators are used to assign values to variables. In the example below, we use the assignment operator equal sign. So to assign the value 10 to a variable called x. So excuse me, that is int x is equals to 10. So the addition assignment operator, which is equals to this one. This is the addition assignment operator, adds a value to a variable. So this one, we have int x equals 10. So if we put x addition assignment 5, so we'll try it. Let's remove this one, remove this. Int x is equals to 10, and then we see out x plus equals 5. So let's try. So if x is 10, let's try this. So it should give you 15. So why 15? So it gives you 15. So why 15? So this is the one. The example was this one, addition assignment operator. So in our example, it was x is equals to 10. So x addition assignment 5 in our example is equals to x plus the number. So here it was x is equals to x plus the x plus 5. So that is the x. So if we run this, x plus 5 is equals to 15. Since x is equals to x plus 5, and x is equals to 10 plus 5 is equals to 15. So that's why if you do assignment addition assignment operator, it will give you this one, this x plus equals 5. This expression is equals to this expression. So if we put the value of x which is equals to 10, it will give you x plus 5 or 10 plus 5 which is equals to 15. So that's why if we run this one, x is equals to 10 and then x plus equals 5, it will give you 15. So that's your assignment operators, the same as the subtraction assignment operator. X subtraction assignment 3 is equals to x minus 3. The same as multiplication. You have division modulus, and then this one and or XOR left shift. So you will encounter this other operators, and this will be under bitwise for the binary. So I will just leave that there, this one, the assignment operators. So the combination of addition and the equal sign. So this one, a plus equals b can be written as a is equals to a plus b. So if your initial value of a is 5, then a plus equals 5, a plus equals 6 is equals to 11, since a is equals to a plus b, and a is equals to 5, and the number is 6. So 5 plus 6 is equals to 11. For the subtraction, yes, the subtraction assignment operator, still the same. A minus equals b can be written as a is equals to a minus b. So in this example, a is 8, so a minus equals 6 will be 2, since a is 8 and the number is 6, so 8 minus 6 is 2. Then you have the multiplication, still the same, a times b, so that this is 5 times 6 is equals to 30. Then you have division, still the same, 6 divided by 2 is equals to 3. Then we go to comparison operators. So you have this one. Comparison operators are used to compare two values. So for the double equal sign, you have this one is equals to. So this is not the same as the it's not the same as x is equal to y and as x is equal to y, that one. this is not the same. This one is different. X is equals to y, while this one it is comparing. Is x equal to y? So that's why this is a comparison operator. You are comparing if the x is equals to y, while this one you are giving a value that x is equals to y, which is correct, which is true. But this one you are asking if x is equals to y. Is x equal to y? So you are comparing two values, so they are not the same. One equal sign and the double equal sign. So this one and this one, you are comparing if x is not equal to y. Is x not equal to y? So you are asking question here. So you are comparing two values. So you have greater than. Is x greater than y? Less than. Is x less than y? This one is x greater than or equal to y. This one is x less than or equal to y. So this is your comparison operator. So that's your comparison operator. Let's try it. X and then int and y. So you have let's just say 5. So we will be comparing it x and y, and also it will give you just two it will just give you two values. So let's just try it. So it should give you 0. So in our boolean, the one that I discussed, the data types, boolean has only two values. It could be true and it could be false. So, but true and false word are not a value in our program. If it is true, it will give you 1, and if it is false, it will give you 0. So, why 0? So you are comparing x and y. So, is x equal to y? Is 10 equal to 5? Which is false. So, it gives you the false, which is 0. So that's how you use comparison. How about we put they have the same value. So if you run our program, it should give you a 1, which is true. Since you are asking, is x equal to y? Is 10 equal to 10? Which is yes, it is equals to 1. It is the x is equals to y. So it is true, which is 1. So that's how you use it. This one, the not equal. Is x not equal to y? So since they have the same value, it will give you false instead, since they are equal. So is x not equal to y? False, since they are equal. So you got false. If we change the number, if we change their value, it will give you true, since 9 is not equal to 10. That is, and it is correct. They are not equal, so you have 1 or true. Still the same, it will give you true or false for this, since you are just comparing two values. So you will be using comparison operators once you are working with loopings and conditional statements. So for the logical, so you have logical operators are used. They are used to determine the logic between variables or the values. So this one, double and ampersand, This is what you call logical AND. Returns true if both statements are true. So like this one, x is less than 5 and x is less than 10. So we put that on the program. This one, let's just put x. So in the example, it is x less than 5, and the logical AND x less than 10. So this one, x is less than 5 and logical AND x is less than 10. So if we run this one, it will give you false. Yeah, that's false. And why? So why it give you false? So in this part, is x less than 5? It is false. And then you have this, and is x less than 10? It's still false. It is 10. The x is 10, so you have false. So the answer will be false. That's why you got the 0. What if we put 11? So let's try it. It will give you the same 0 or false. So for this part, is x less than 5? It is false. And is x less than 11? It is true. But it is 0 and 1. And the description of logical AND returns true if both statements are true. So are both statements are true? No, this is false, so it will give you the same false value. What if we change this to x is greater than 5? So let's try it. It will give you true. So why is it true? Is x greater than 5? Is 10 greater than 5? Yes, it is greater than 5, so it gives you true. And then, and logical AND, is x less than 11? Yes, 11 is less than 10. No, 10 is less than 11, so it is still true. So the answer a while ago is true. So you give that true value 1. So that's how you use logical operator. If 1 is false, then the final answer will be false. But if it is both true, then it will give you true as an answer. But if you have either one of them false, it will give you already false. So that's for the logical AND operator. Next is logical OR. This one, logical OR. Returns true if one of the statements is true. So example, we change this to logical OR. So this one. So it will give you true. True is the answer. So why true? So for this one, is x less than 5? It is false. Or is x less than 11, which is true? So in the description, logical OR returns true if only one of the statement is true. So one of the statement is true, so your final answer is equals to true. And it's still the same. If this is false and this is true, it will give you true. But if both are false, then it will give you false. So that's the logical OR. And how about the NOT? Logical NOT reverse the result, returns false if the result is true, and vice versa. If the result is true, it will give you false. If it is false, it will give you true. So for example, this one, and we put NOT operator there, and we try it, it gives you false. And why? So let's try this. Is x less than 5? Yes. And then OR, and then is x less than 11? Yes, it is true. But this is under the NOT. Not sign, so you have not here. So this one, since this is 1, since 1 or 1 is true, and not will reverse the result, so it is equals to 0. Let's try it again. It gives you 0. How about if we do a false? False is x greater than false, and this one, x greater than 11. So, and you have the NOT here, not logical operator. So if you run this one, this is x greater than 5, it is false. Is x greater than 11, this is false also. So it will give you 0. Oh yeah, this is x is greater than 5, this is true, so it gives you true, so it gives you false. Let's try this one. So this is false, and this is false, and this whole or false or false is equals to false. So let's try it. It will give you 1. Yes, it gives you 1. It will reverse the result if you put NOT on your operator. This one, the NOT operator. Since this is false or false, and you have the NOT. We have the NOT here. So false or false is false, but you have the NOT. So not false is equals to true, which is equals to 1. So it will just reverse your result if you put NOT on it. So that's your logical. And for the bitwise, yeah, just I will give you another video for this one, the bitwise operators. So just an overview. So bitwise operators works on bits and perform bit by bit operation. So this is the truth table. Example, you have variable p and you have variable q. So this is the truth table. If p and q, it will be 0, meaning 0 and 0 is 0. For this one, 0 and 1 is 0, 1 and 1 is 1, 1 and 0 is 0. So if you use AND, bitwise AND, if 1 is 0, it will give you 0 as a result, like this one. 0 and 1, 0. 1 and 0 is 0. So if either variable is false, it will give you false directly. But as a for OR, you have this one, P or Q. So if 0 or 0, it will give you 0. 0 or 1, it will give you 1. 1 or 1, it will give you 1. And then 1 or 0, it will give you 1. Meaning, if there is one statement that is true, it will give you true directly. And for the XOR, this is a different one. P XOR Q. 0 XOR 0 is equals to 0. 0 XOR 1 is equals to 1. 1 XOR 1 is equals to 0. And 1 XOR 0 will be 1. So this is different. So if on XOR, if both values are 1, it will give you 0 or false. So if either you just have one, if the one statement is true, it will give you true. But if both statements are true, it will give you false. So you just need to have 1 here and 0 give you 1. If you have both true, true, and true, it will give you false. So that's the overview. I will be giving you a different video for this one, so just stay tuned on our Edmodo class. And we will be having our video conference for this one also. So thank you, and hope you watch this video and keep safe. Good luck, students. Peace.